Another important topic in sampling is margin of error and sample size. So before we get to those, I want to define inference. Inference is the process of drawing conclusions about a population on the basis of sample data. We all know that different samples from the same population will vary from one another in the results we get. So how do we quantify how much variation we are likely to get? To examine that, I want to look first of all at a newspaper article. That's from the current election cycle. So we have this newspaper article that says, after the Democratic convention, that Clinton polled ahead of Trump in the polling results. It says the former Secretary of State has a support of 46% of registered voters compared with 39% for Trump. Well, obviously they didn't interview every single person that is a registered voter in the entire United States. They took a sample. Specifically, they took a sample on July 29th through 31st of 1,131 registered voters. It says the margin of error is plus or minus 3 percentage points. What that means is that we can typically expect that the samples drawn of this size from the population could vary as much as 3% above or 3% below the results that we got. So in other words, Hillary's support really could be anywhere from 49% to 43%, and Trump's could be anywhere from 36% to 42%. So in actuality, they could be only 1% apart, or they could be, instead of being 7% apart, they could actually be 13% apart. So there's a lot of variation within the samples based on sample variability. So to test this, I went to a website that allows me to take random samples, many random samples from the same population. So I set the population mean to be 46%. So in other words, the average, the sample, the proportion of the entire population to be 46%. And I took, actually it says 1,000 random samples. I guess I actually took 1,005 random samples of size 1,131, because that was what the article said, from this population. And you'll notice that they all centered around 46%. You'll also notice if we add that 3% margin of error in there, okay, so 49% would be right here, and 43% would be right here, that the vast majority of the samples obtained are within that 3% margin of error. Now, did we get some samples that fell outside of that? Yes. But they were highly unusual. Out of 1,000 samples, we probably had less than 50 that would fall outside of that plus or minus 3% range. So what that 3% margin of error is the typical amount of variation that we expect to see in a sample of this size from this population. So here's what I defined it to be. The expected amount of value obtained from a sample might vary from the population value. So it's expected, it's not the unusually high or unusually, but in general, what we expect. Now another activity we did in class was to sample from a tub of red and white beads. So I have this big tub of red and white beads, and I have these paddles. It looks like a little piece of pegboard with holes in it. And we stick the paddle into the beads, and it comes up with a sample. We first did samples of size 20, just using the lower 2 rows of this paddle. And these are the results we got. So taking 3, 7, etc., each of these divided by 20, I came up with these percentages. So based on these 11 samples, we could have estimated that the proportion of red beads in this bowl was anything from 15% to 45%. Quite a large range. But then we took samples of size 100, completely filling up this little pegboard, and counted how many red beads we had. Using those results, we saw that they range from 21%, actually I think I forgot the dot at 21, there we go, one more, oops, that should have been blue, 21% all the way up to 33%, okay? But that's a much smaller range than 15 to 45%. So we saw that using a larger sample reduces the margin of error, the amount of variation we expect among samples. In other words, we'll get a more precise estimate with less variation from the true sample proportion, or the true population proportion, if we use a larger sample. Now, just a comment that in a political poll, they had a sample of 1,131, which gave about a 3% margin of error. And you might think, well, I'd like to have a less margin of error than that. Well, it turns out that doubling the sample size does not reduce the margin of error by 1/2. It only reduces the margin of error by 1/4, and we'll find out why that is more second semester. But it would be cost prohibitive to have much of a larger sample than that. So generally, 3% margin of error is considered acceptable in political polls.